Everybody, it is 10 o'clock. Actually, it's not. It's 11 o'clock. Oh, actually, so this is wrong. I should change that. It is 11 o'clock where I live. Starting an hour late because it's been a thing. Hello, Azitsu. Wonderful to see you. So I have been on the road a lot for the past week and a half, 2 weeks. And Friday I drove from Paducah, Kentucky to Oshkosh, Wisconsin. And then yesterday drove from Oshkosh, Wisconsin back here home and got home kind of late. And so it was good to sleep in a little. And so I'm going to be here doing stuff. And then I'm going to go plant plants in the garden while the soil is in good shape and not too wet. And before we get more rain here in a couple of days. So yay. Thanks for joining. So I'm not entirely, I have nothing resembling a plan for today. Other than I got up and I'm here and we're functioning. So there is still work, I think, to be done on READMEs. We've been working on the READMEs. Oh, hello, that was weird. Not what I had in mind. I'm actually going to change this, which I'll then forget to change next week, and it'll say 11 to 1 when it should say 10 to noon, but such is life. So we have been working on, yeah, fine. I don't care. READMEs for the different libraries, and we'd gotten through a pretty reasonable, let's close that, start on the primary README. Yeah, we don't care about you. Where we went over the project structure. There's a couple of gaps here still to be filled in. The aspirations, goals, and how to get started. We have a EC Core README that now has this nice diagram that sort of illustrates an example of a kind of evolutionary computation process that ties into our various types and structures. So that's kind of cool, and outlines some of the key pieces. So I think we've made progress there. And then we had started last week on EC Linear, and we had listed some of the operators that are supported, and had even gotten excited and drawn a diagram for one of them. And I think there are probably more diagrams to be done for some of the others. UMAD's a little weird and takes some getting used to, and could be documented more. And it would be nice, like if this ever got published as a crate, so that there was documentation on docs.rs to link to the relevant documentations from things like this, UMAD here. But until such things exist, there's not really a good way to link into the documentation. We could link to the RS file, but I don't know if that would be very helpful. No, I mean, I expect it wouldn't be that hard for people to find things because I think we've named the files reasonably. So I don't know that the link would be a big win. So this is where we left off. I don't know that there's much left to be done here. We could make more diagrams, but I'm not sure that that's the best way to use the time at the moment. So let me look at EC Linear. Is there stuff in EC Linear that we need or want to say something about? So it provides implementations for basic tools for evolving linear structures such as bit strings and plushy genomes. There's support for fixed length and variable length linear genomes. And that probably tells us most of what we care about. This trait doesn't really do much. Except for the gene mute is probably the most interesting piece of that. And bit string. So yeah, this probably ought to be, there probably ought to be a linear genome struct that's generic in the type of its thing, and then both bit string and plushie would just be linear genome of the right thing. And that's sort of what vector kind of does. And maybe it just ought to have a different name. I think this is all, all got a little confused. It was written pretty early on, and I was still figuring a bunch of stuff out about Rust and how to do this kind of design. And I don't think it is super clean. In fact, I think there is, let's see, do I have, there we go. I think there's an issue about vector and bit string. Yeah, okay, here we go. I think I'm also going to note keep vector but rename it as linear genome T. The name vector might be read as implying fixed length genomes when the actual implementation is more general than that. Is and should be more general than that. Okay. So I kind of think actually linear genome might be the thing, although we could just, like it says, like I said here, we could just implement linear for vec_t and not even have the vector T wrapper. And then bit string just becomes, so actually what would, let me save that so in case I forget. What would bit string lose? What does it do that, if it was literally just a vec of bool instead of wrapping a vec of bool, would we care? All this distribution stuff. Hello, Eustace. Oh, little warm where you are. Yeah, it's going to be warm today and a lot warmer tomorrow. Actually, very similar to your temperature tomorrow. And then a line of thunderstorms is going to come through, and we're going to rain on Tuesday. No associated methods without a trait for one. So if we had, so if we just implemented linear for vec_t, if we wanted some of these other methods, we would have to have traits that vec_t implemented. So to catch Eustace up, we've been looking at the EC linear README, and I was just looking at what all EC linear did, and we're looking at bit string and vector, and that took me to this issue. Oh, no problem. Cleaning up the kitchen's important. We don't like scary things in the kitchen. And I'm shifted a whole hour, so confusing the world. It's an hour later for folks out like you. Actually, it's an hour later for everybody by definition, but that has maybe more impact for people for whom it's later. I don't know. Um, I hope not. That would be bad. I'm glad you were cleaning the kitchen rather than just sitting here for an hour wondering where I was. So yeah, right now there's this vector, and there's a to do in the code that says, well, maybe we should rename that linear genome. And I sort of feel like that would be the thing to do, actually. Um, but we're not doing that right now. I was just sort of stumbled into it from looking at the README. So I think we don't have a whole lot to say here that hasn't been said. And then we've listed the mutators. And is there anything in mod that we care about? No, mod just republishes things. And we've talked about the recombinators. Yeah, so crossover is just the general trait. And then we have the errors. We could make fancy graphs for the mutators and combinators. It depends on, is that the most important thing right now. So if we look at, okay, go away. It is fun, and so it could be a thing. Uniform, we could actually basically steal this and then change some of the coloring and the arrows. UMAD's a little tricky. Actually, UMAD, we could, instead of having two parents and a child, you could have the original parent, the parent after addition, and then the intermediate vector after addition, and then the child after the deletion step. So again, we could basically copy this diagram and use a variant of it as a starting point. Are in Excalidraw, are these squares actually individual components that we can remove or add? Because I know this came from a template, but I don't know if this template is implemented as like this is one really long line with little lines between. Oh, they are individual boxes. Okay, that's good. Because then we could add some boxes and delete some boxes. And that would be a thing we could do for UMAD. And oh, sure, that makes sense. So your hashing here fit inside the box, and that's how you could treat the boxes separately. That makes sense. So let's maybe focus on some of the other text first, and then if we have time, we can come back to drawing pretty pictures, because I think the pictures are fun, but I think there's words that need to be written. So I think that EC Linear, ignoring the pretty lines or pretty pictures, is in a reasonable place. Hello, Define Evil. Lovely to see you. We are doing README stuff for the Evolutionary Computation project. So I think we're kind of okay here. And then, EC Linear, push, so we don't want to say a whole lot here, because, so we probably should say, it's probably worth saying there are essentially two components to this package that probably should be split into separate packages. The push interpreter and the evolutionary computation, or the algorithms that allow us to evolve push programs. Oh wow, that's cool that you're going to get to write what Rust at work again. That's nice. You can call me whatever you like. I didn't mean to. Oh, I didn't mean to have a smiley here. This is the end of a parenthetical, and that's a colon. So yeah, I don't think that was meant to be a smiley. So if Define Evil wants to call me Mr. Prof, Define Evil can, but Define Evil can also call me Nick. I don't care. It's all good. Okay, so we have that. The push interpreter, there has been a lot of discussion of the design of the push interpreter, and that should absolutely be considered work in progress and liable to change without notice. Yeah, definitely a frowny face. Okay, so yeah, this is likely to be so your pre-university school was very different from mine, because I know I didn't touch anything like DFAs, NFAs, pumping lemmas, and etc. Until I was a few years into university. So you had a very detailed computer science education before you got to university, in a way that I did not have. Ooh, that's too bad. That's too bad. Oh, you just studied it for fun. Well, that makes more sense, because I'm like, what school would be teaching like 16-year-olds pumping lemma? That doesn't make a lot of sense. So, yeah, we were just in Paducah, Kentucky, last week for several days. So that's in far western Kentucky, and similar in some ways to Southern Virginia. Well, I mean, we're all here, which implies certain shared notions of what a good way to spend 2 hours of our life is. So I didn't have any computer science in school, but that was in, the 1970s. So things have changed some, but it is a bummer that there's not. Minnesota, where I live, is actually quite behind on computer science education, and this is not something that the state's doing a very good job of addressing. It's a long story, probably not for today's conversation. Okay, so say the current interpreter has support for integer, floating point, and Boolean instructions, and some work has been done on character instructions. It's a significant weakness at the moment is that you can't add instructions without modifying the package directly. Boom. So the European school systems and American school systems, nothing quite lines up right. And I'm more familiar with British systems because my wife is British than I am German systems. But yes, we would have primary, often middle school, and then secondary. We would tend to call them elementary, middle school, or junior high, and then high school. But primary and secondary map reasonably well. We often have this intermediate piece. And our secondary runs to 18, whereas like in the UK, there's the whole college thing, which is between secondary and going to university if one goes to university. So it doesn't map perfectly. Yeah. So, and I think you do get, there are schools where people learn like some HTML and then they think they're programming. You know, we could talk about that, but there's not much beyond that, I don't think. Yeah. So, although you can do a lot in Excel, and if you're just like, if you're new and you're just learning to program in Excel isn't great, but it's probably better than a kick in the teeth. And now, of course, there's the Python. I'm sure those tables held up very well over time. I made a lot of table-based web pages back in the 90s. Oh my, did I make a lot of table-based web pages in the 90s. All in, of course, by hand in raw HTML, because that's what one did. The recent announcement that Microsoft is allowing you to program in Python sort of directly, or program Excel directly using Python. I haven't chased anything past the headlines, but that's a potentially interesting change and could make actually programming in spreadsheet land a lot more interesting as a sort of an actual programming universe. I've done a fair bit, it's been a few years, but I've done a fair bit of programming in Google Apps Script, which is their version of JavaScript for their Google Apps universe. So it's basically just JavaScript, but it has kind of built-in libraries to let you hook into their apps, so you can go to a calendar and your calendar app and query for stuff, or there's APIs for talking to a spreadsheet and inserting data or extracting data. You can do stuff with your email. And if you don't mind writing JavaScript in a web editor that isn't all that great, it works. But it isn't what I would call tons of fun. Oh, that's too bad. Never fun to have somebody who's kind of a jerk managing a project. Yeah, that's unfortunate. And it's always tricky. Like, these people are volunteering their time, so it's hard to yell at them. On the other hand, if they're hurting the project, it would be nice if somebody could, have a conversation on the side, sort of a grown-up conversation about what's happening and how we can maybe make it better. But that's a hard thing to do. And with open source, you know, I don't really know any of you. I mean, I have learned a lot about some of you through literally years now of chatting online. But, you know, it's not like we can sit down over a beer and, you know, have a conversation about these things. Yeah, exactly. Everybody's volunteering their time, right? And you would like to see the project move forward and be healthy. And that, yeah, these things are hard. These things are hard. And I've had the privilege, and I think it is a privilege, of mostly working on projects where I've had direct physical, personal interactions with people. So grades 1 through 4 are usually our elementary school, and then you have 3 different kinds of secondary school paths. Hauptschule, which is more focused on practicalist education, going usually to grade 9 or 10. And then we have Realschule, which is similar but usually a bit more academical. And then we have, and I bet there's another piece being typed as we speak. No problem. So and I assume the third one's kind of the one aimed at people who are going on to university, which is kind of like you don't have to do the college system in the UK. Go to college in the UK system. You could stop at, I think it's 16. But if you're going gymnasium, which is more focused on academics, with the intention of going to university. Gotcha. Well, I think companies often under-assist. Yeah, this is, I think, one of the big differences between American systems and a lot of European systems is you have to make decisions pretty early. So, you know, you're making a path quite early in the kid's life, which is going to affect in a significant way what some of their options are downstream. And that can definitely happen also in the UK system. And the American system, for better and for worse, I mean, it cuts both ways, tries to be more open for longer. Yeah, and at a lot of European universities, like, you have to declare as part of application what you want to do, and you just do that. So, you know, you go and you study that subject. And if you decide halfway through that was a terrible choice, don't always have a lot of options for moving around. And that can be real challenging. And certainly, you know, having taught here a long time, the number of 18-year-olds that know in a meaningful way what it is they want to do is very small. The number that think they know what they want to do is much larger, but many of them realize that they're wrong. And that's not a criticism of them. I mean, I think that's just, you know, how much do you know about the world when you're 18? And do you really know what it means to be a computer scientist or a historian or a philosopher or a painter? You need a Fachoberschulreife mit Qualifikation zum Besuch der Gymnasium Oberstufe, or 4Q, to be allowed to go through grades 11, 13, after which you can get the Abitur, which is our qualification to go to university. And so I assume, like, if you went to a Hauptschule, would it then be difficult to get a 4Q? because you wouldn't have done the right things before that. Or you'd have to study on the side or something to get a 4Q. Yes. And I probably didn't do a great job with the German. My apologies. But yeah. Yeah, very German name. You can totally understand why they gave it an abbreviation. Yeah, so you could do it, but you would have to, and you'd be coming into a school where a lot of the other kids know each other from previous schools and you wouldn't, so you risk being a bit of an outsider or a lot of an outsider depending on the circumstances. But at least it's sort of possible. So, okay. So the current interpreter has support for integer, floating point, and Boolean instructions, and some work has been done on character instructions. So you can't add instructions without modifying the package directly. I think that's then all gone. Oh, we probably should mention on EC Linear and here. So the examples directory. I think I don't go up one. Yeah, there we go. Has several examples of evolving, or 4 maybe is better, 4 evolving solutions to both symbolic regression problems and software, let's see, as well as software synthesis problems from the PCB1 and PCB2 benchmark suites, and those should have links. So if you didn't manage to get an abitur, so getting an abitur means doing well enough on the exam to go to university so that you can get a Fachabitur. So Fach is subject, right? Or major, or yeah, kind of area, I think. Because Hauptfach is major, like your area of focus. And then there's something else Fach that's minor, if I remember correctly. After going to vocational school. Okay. Oh, that's nice. And so then it's kind of a matter of you would have to then prep for the Fachabitur kind of on your own, and how hard that's going to be probably depends, at least in part, on what you did in vocational school. No, I think you're doing a great job. Thank you. And it's interesting to see how different countries sort of handle these things. So vocational school, would that include things like simple electrical engineering, or would that be the kind of thing? Because I could imagine you could do a 2-year degree here. Gotcha. But if the would typically the Fachabitur be, would you typically transition to a somewhat related? So if you did electrical engineering in your vocational school, that might be a lead-in to doing certain kinds of computer stuff, electronic engineering or computery things. Whereas if you had done woodworking in your vocational, a fac abitur to get into computer science, you would have had to have done a lot of studying on the side to be able to pass that exam, because you wouldn't have gotten much related experience in vocational school. And that's not completely unlike some things here. So we have what are usually called technical colleges or community colleges. And they're usually 2-year degrees, sometimes called associate degrees in the United States. And so you can finish high school, say 17, 18, and then you could go and get a 2-year degree. And those are often in vocational things. And there's actually shorter, very specific vocational things. So you could spend 6 months and be able to go out and do, say, plumbing or welding, certification kind of stuff. But you could also do a 2-year degree and have a variety of skills. And that might be more like the electrical engineering or the car mechanics or network administration kind of stuff. And you'd be the kind of person that would, wire everything up. And we get students that transfer to Morris from 2-year programs like that. So they'll complete a 2-year program and then they will come to us. And the state runs the 2-year programs, and we're part of the state system. So there are arrangements in place so that if they complete the 2-year degree, they can come to us, and we guarantee that will satisfy a whole set of requirements. So they don't have to repeat that at Morris, and they will basically then just focus on their major. And so in computer science, we get not a huge number, but not a trivial number, few a year at least, students who transfer in from other places with 2 years of usually some kind of related experience, and then want to complete a full computer science degree. And that can be a lot cheaper for them as a pathway. And I think that kind of path is available most places in the United States in some form or another. But you'd have to apply and get into Morris, but there wouldn't be a specific computer science exam you would need to pass. You just need to convince the admissions office that you could cut it at Morris, and that would work. So I need to look up links for PCB1 and PCB2. I clearly should have cleaned up my tabs. PCB software synthesis benchmark suite. What does that take us to? Okay, so that's actually about some code. That's probably not really useful here. So I think we might be stuck going to articles. We can do that. And I guess really technically, I think this is called that. Yeah, do I want it? I feel like there's a published one that would probably be the better choice. Oh, we could just link to the DOI. That's an interesting idea. Copy link. I like DOIs too. I think that's a good idea. And so actually then we want to come back to this one and grab the DOI from that. Copy link. And then if things move, we're not tied to ACM's particular structure, etc. Actually, I think I want the article to be inside the link. I want the article to be inside the link. There we go. That's nice. Sure. This one or the second one? The second one. So this is the non-archive X version. Oh, PSB. Good catch, Justus. Wah, wah, wah. That would have been bad. Well done. Thank you. I think it's Program Synthesis Benchmark is what PSB stands for. Yeah. PCB, not the right thing. Definitely the wrong answer in this context. Oops. So thank you for catching that. I wonder if there are other places. PCB. Oh, good. And I do link to PSB and PSB2. Oh, just in this README. Okay. So that's boring. But at least I didn't say PCB somewhere. So that's good. Okay. Yeah, no, thank you. I appreciate you catching that. That is good. So I think actually something like this probably ought to be in the EC linear README. So what's in the examples directory in EC linear? I don't remember. So just a couple of binary has few examples of performing evolution on bit strings. Boom. We could. Actually, I think that wouldn't be a bad idea. Should the examples section then come before the operators or after the operators? Yes, examples. Yeah, probably after, I guess. So we have, I think, at the moment, just count ones and HIF. Oh no, I think it is a dash, right? No, it's going to be an underscore. Yes, it is going to be an underscore because We can't have, this is not Lisp. We cannot have dashes in our names. Yeah. So count ones, yes, but count ones isn't a package, so that equivalence is not relevant here. It would apply to EC linear. Count ones is a package? So are all modules particularly? Oh, examples are packages. Really? Really? Okay. Is each example a separate package? Huh. Okay. Well, that's interesting. Where the goal is to maximize the number of ones in a bit string. And if based on, I'm gonna get, I knew that every binary, no, did I know that? That's interesting. Okay. So actually I wanna, can I find the HIF problem? HIF, genetic programming. So I know we cited it here. No, I don't want that. Related articles. I'm gonna have to actually look at a PDF, aren't I? Citations. Oh, that is definitely not helpful. Let's go back to our paper, because that definitely, oops, can we just do that? Here we go, because I know we cited the right paper. Show all references. Where is that paper? So it's Watson. I think it's this guy here. Well, no, here. Is it this one? Don't remember. It's definitely one of these Watson papers would be the one I want. This one's in the library. Oh, no abstract available. That's really not helpful. Boop, boop, boop. Oh, great. Couldn't even find that one. I feel like this is the one where he introduces the problem. Yeah, okay. He defines the problem here. That'll do. Point at that. Now, do I have a DOI on this? I do not appear to. Oh, here we go. This will have a DOI, right? Yay, DOI. Copy link back to here. Hierarchical if and only if problem. Boom. Bop. Bibbidi bibbidi boo. Oh, that's right. It's down here now. Okay, cool. I should catch up. Yes, so they are seen as their own thing by the compiler. And you see that, examples. And you see that in the imports. Like they don't have any particularly privileged status as far as imports go, which makes sense, right? That when you import, you're doing it in the same way that somebody outside the project would import the components of your project. Oh yeah, so it's clearly paywalling and all of this is a mess. And yeah, and unfortunately, right about main.rs. I think there were forces at play, at least in parts of the world in the U.S., to try to reduce certain kinds of paywalling. But I think the current government is undoing a lot of that. And so I suspect this problem of paywalling is going to get worse before it gets better. Yeah, but I have been on the editorial board in a minor role for a Springer journal for probably 20 years now. Is that really true? That seems like a very long time, but for quite a while. And it's a weird deal. Yes. So my mother gave me this. The idea is that was the year of COVID, and so nobody really liked it, at least over here. And I think that's probably true for lots of places. So my family gives me all kinds of strange shirts because they know I'll wear them. And I guess if we really wanted to be fancy, we could come up with a reference for OneMax. What would be the... Let's go to Scholar. OneMax Evolutionary Computation. Yeah. Oh, so sad. So sad. So there's that problem is an old problem. And trying to find the original reference to OneMax is going to be hard. Hindley Milner Inference t-shirt. Nice. I like that. That's cool. Yeah. That is very fun. I get these shirts sort of nerd shirts like that. And my mother's just like, I don't understand. It's like, well, I don't think you're the target audience, Mom. I wonder if I were to say, what academic paper introduced the 1 max problem in evolutionary computation? I wonder if their little summary will tell us something useful. No single paper can be definitively attributed to introducing the problem. Yeah, I think it goes back so far that it probably isn't meaningful. I wonder if there's a Wikipedia page on 1max. Wikipedia 1max genetic algorithms. No. 1max. Nope. Oh well. Well, you know, the Hindley-Milner thing is a little, obscure outside of a narrow window. Evolutionary computation 1max problem. Yeah, I don't know. I see anything that would be worth linking to. So I think we'll just leave that one alone. I think people can find stuff. And the description is pretty straightforward. Whereas HIF's a little weird and requires probably looking at something. So that goes there. Copy URL. Oh, here we go. Yeah, that's not terrible. We can do that. That's actually sort of a nice set of little examples. Hey, Vagri. What do you think would make sense to link to for the 1max problem? Oh, I could link directly to the relevant section. That's a good idea. Yeah, copy. What have I done? I did a thing. Oh, weird. What did it do there? No, that did the right thing. That's so strange. What happened the first time? Boom. Okay. Now it seems happy again. And Vagri is left, so we will never know. Maybe. Oh, maybe, yes. Paste. Oh, look, you're right. Yes. So it made a link out of that, linking to the thing that I pasted in. Oh, very smart. Well done. Which is actually not an unreasonable thing to do. That should be an implementation of. I didn't know that worked either. Obviously, we all learned something today. Hurrah. Limit problem goals, maximize the number of ones in a bit string, if, based on Watson's hierarchical if and only if problem. So voila. And then that suggests, to be consistent, we'd want to probably have an examples section here. And oh, I see, yes. So these we could link to examples count ones. Should I go just to the directory? Ah, that's a good idea. Yes. Should I go to just the directory or go all the way to main? Probably just the directory, I guess. Yes, args, that was part of what I was thinking about, is args isn't that interesting. So we could go to main. Oh, that was weird. So it actually hopped us there in VS Code, which I guess is kind of makes sense. Sorry, vagary. Okay. So those link there. I think that's useful. And then back to board push go push. Now, do we think we should list all the the question was, let's go back to linear. So for the HIF problem, I linked to an article by Watson where he introduced the problem. And 1max is so old and ubiquitous, it's not obvious what would be a reasonable thing to link to. And Justus found this website, which is, I think, has a pretty reasonable discussion of it. There's not a Wikipedia page for 1max. Probably ought to be, but there's not one. And as you know, the other old EC person in the room, I thought I would ask and see if you knew or had thoughts on. We've had a lot of issues with Wikipedia as a field. I was a little surprised that 1max wasn't there because I think the GA people, genetic algorithm people, have had better luck with Wikipedia than the genetic programming people, but whatever. So I was just curious if you had a thought on what would be a reasonable thing to link to for 1max. It's such an easy problem. It probably doesn't really need a reference, but it, could have one. So if you have thoughts, share. So push, we've got 5 examples. Is it really a benchmark? Hello, bird. There's a bird outside my window that is being very noisy. Although I think the theory people have used it as a problem to study at great length, perhaps with limited value, but so I guess, is calling it a benchmark. And here we just say it's examples of performing evolution on bit strings, so I don't call it a benchmark. Um, and actually, this should see the classic 1max problem. Oh, no, it does say problem. But it should be in here, though. Comma. Yes, it does have great pedagogical value because it's easy to explain as a starting point. And, you know, your acceptance test description is actually pretty accurate because I wrote this example as, in some ways, an early acceptance test that we had the design working well enough that we could actually do the 1max problem. So it was a test of the framework, like, hey, does it work? And it did. So yeah. And I did HIF because I wanted something that was a little harder, that you didn't get a solution almost instantly every time. So okay. Back to push. So, Justus and others, do you think we should link to all the push examples in the same way that we did here in the EC linear examples? I mean, I'm guessing the answer is yes, but oh, actually, it does not describe, that's an interesting point. It does not describe circularized 2-point crossover. And, you know, we could have a conversation about why 2-point versus 1-point and because of the ends. But no, it's just straight up 2-point crossover. That's the intention. So if we want to list a few of them, we did straight. Probably worth listing at least the 3 PSB benchmarks. The regression ones are kind of arbitrary, and don't have great names. Yeah, we could. I mean, there's a lot of operators. I mean, the evolutionary computation literature is full of millions of random operators, many of whom were only used in the paper where they were presented, and there is no good evidence that they're actually very useful, or more useful than the standard ones. But sort of the minimum publishable paper has often been, I've got an idea for an operator. It's better on some problem than the standard operator. I will publish the paper. Yeah. Oh, you're reviewing GPTP stuff. Has GPT happened? Genetic programming theory and practice. Has GPTP happened, or is it about to happen? The semester. Oh, Wednesday. Wow, you're a busy person. The semester completely got away from me. I got a nice email from Wolfgang saying, hey, do you want to come? And I was like, oh, I just can't really see it happening. So I'm being bad and not joining you. Apologies. So hope maybe next year. It'd be nice to come back. Well, there have been people that have done sort of meta operator stuff. And that can happen at a variety of levels. So you could do things like evolve the mutation rate. So you keep the operator, but you evolve the parameter that the operator uses. And then there have been people that have looked at doing things like selecting between operators with different proportions, and in some cases even modifying the behavior of operators. So that's been done some. I don't know that as a rule that's ever been super successful. But I think there's potential there that we have not capitalized on. Yeah, exactly. All sorts of LLM stuff that could be done. And the or infinity is completely the thing. There are a million ways you can do this stuff. And one of the things that's tricky with evolution is almost anything that you try can appear interesting by some definition in the right light. And by in the right light, I might mean a little p hacking. Depends on how cynical I'm being. But for almost anything you try, there is almost certainly a problem and a set of conditions for which that thing is interesting. And because there is this intense desire to publish, people are very good at finding that set of conditions that make their thing look good enough to get past a reviewer at a conference and get published. So there's a lot of literature on that sort of stuff. And a lot of it's not super great. That's my humble opinion. And I will, just to be super clear, I have published papers like that. So Vagary has mostly not published papers like that because Vagary mostly doesn't publish things. Yes, we actually have a Eustace. I think we have an issue. I hope we have an issue. I think we have an issue that is getting the nope, not there. Here, I think we have an issue for downloading their data. Download. Nope. PSB. Nope. Really? Do we not have an issue? Training. Right here. Wow. So I somehow managed to write this without any of the keywords that I then tried to use. So actually, if I change this to downloading instead of getting, that would probably help. And I could also say training, testing, to make it clearer what's going on there. Yeah, so it would be totally good to be able to just grab these things since they've got this nice online collection of training and testing cases. So we'll mention the three median, number, IO, and smallest. Examples, median, main, which finds the median of 3 integers, I think. Examples, number, IO, main, which converts an integer to a float, and then let's see, adds it to a second float. Boom. Oh yeah, I guess in our case that's I64, and if we want to be picky here, that's also ordered float. I think it's I64 in our case. Oh yeah, thank you. Ordered float what? F64. So let's see. Vagary says, question would be, do you want examples that demonstrate things about GP for teaching and stuff? I think ultimately, well, I'm not likely to, and I think actually we should do the birthday problem. I think that would be a cool problem to do as a nice example. And it would illustrate harder kinds of regression. I'm not likely to teach an EC course ever again now that I'm sort of beginning to retire. So the birthday problem, so this is actually a vagary thing. So you create a number based on your birthday. So I don't remember how you exactly do it, whether it's like day, month, year, month, day. But you take, like in my case, it might be 1963, 06, 25. And you give the evolutionary system just like 0, 1, maybe 2, some small numbers to start with, and the arithmetic operations, and it needs to evolve an expression that has the target value, and that is difficult. No constants at all initially. Well, you have to. So you give it some input x, and so then it can get 0 by doing x minus x, and it can get 1 through like protected division, and then it has to like build up from there. And it's tricky because evolution is often pretty good at like making big numbers, but it's not very precise about making big numbers. So you can like jump up to a very large number, but then it's got to like tune that to be the big number you actually asked for, and that is getting close is hard. And Vagary's got a lot more experience actually doing the birthday problem in different settings than I have. But it would be a simple example to include, and I think would be useful. So it would be a nice thing to have, but we do not have it at the moment. Smallest main, which finds the smallest of how many? I think it's 4. And where is my, main's at the top here. Where do I build the test case? Score genome. No, that's not going to be helpful. Where do I build the test cases? Hello. Da, 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 da. Instruction set, training cases. Okay. Yeah, so it's the minimum of 4 integers. Okay, there we go. If I had looked here, I would have been okay, but I didn't. So the minimum of 4 integers. Boop-a-doop-doo. Smallest of 4 integers, and again, those are, I64, because that's what our stack supports. And let me check while I'm here that median is actually, yeah, it is integers. Okay. I was pretty sure it was, but good to check. Oh, yeah, fine. Da, 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 da. There we go. Oh, so base and shift might be an interesting idea as an instruction. I don't know. I'm sure somebody's done it. It seems like kind of an obvious thing for somebody to have done. But I don't know that I don't think it's in commonly used systems particularly. Well, I think so that Vagary's most recent comment, I mean, one of the things Vagary is very good at reminding people of is point 3, that they're often not trying anything that's very hard. And so things work, but mostly because you're doing something that isn't very difficult, which is one of the reasons why it makes sense, for example, to always test your system against random search or a hill climber. Because if they can solve the problem, then the fact that you also solve the problem isn't very interesting. Because, hey, we generate enough random solutions. And so, like the birthday problem, a bunch of random programs are not going to get you there. A hill climber maybe gets you there, depending on what you have to work with. But certainly random search is not going to get you there. Gotcha. Yes. And I don't think I came back and fixed that. I meant to, and then I got distracted by the other parts of the conversation. Thank you. And prints the result. I think that's true. Is that true? Do we print? Actually, I don't think we do print. I think we actually just get the result. Yeah, I think we just get the result. We didn't have Levenshtein distance built in yet. Oops, what am I doing? Yes, and the cargo thing. To run an example, it's not Rust actually. That's more bash. Cargo run minus release minus example name help. Actually, okay, I'm gonna do this twice. Oh, come on, fine. parameter settings to see the cannot spell parameters for a given example. Boom. Do that. And now, okay, good. There you go. So this assumes you have Rust up, well, Rust installed in some fashion, but Rust up would be the recommended approach. And if you clone the repo, you can do this and it should work. Zippity doo dah. So like, yeah, cargo run -- release, and you don't have to have the -- release. That just causes it to compile in non-debug mode, and it will go a lot faster. And so unless you plan on doing some crazy debugging stuff, definitely recommend the release option. -- example, I don't know, let's do median. And we can just go and it will do everything. So we succeeded in 11 generations with this behemoth. One thing, it might be worth mentioning in the thing, if we do the -- help, we get the flags that are available, and I have definitely found that you get much more readable results if you start with max initial instructions being small. One sometimes doesn't work. Oh, yeah, there we go. So it takes more generations, but it often is faster just because you're working with smaller programs. And it's easier to think about them, usually. So this is useless. This puts a 1 on the stack. That puts a false on the Boolean stack, which probably doesn't matter. This multiplies the 1 times C. We don't do anything. We dupe that Boolean. Why? I don't know. And then we put 1 on the stack again. We consume it. We finally get around to doing the work. We put A and B on the stack. So now we have A, B, and C on the stack. And we did a clamp. So we duplicated this clamp with the yes. And that did all the work. So it clamped C between A and B. And then I think we're done at that point. Is there any caching or memoization of fitnesses? There's nothing fancy. I'm not sure, like, if we have the same program twice, it will completely rerun that second program. No, I'm pretty sure that our interpreter, the compiler, is not going to be smart enough to kind of recognize that those two programs are the same. It is just running the thing twice. Now, part of the reason that looks fast, though, in fairness, is if you look, saying these are implementations of PSB and PSB2 is a little dodgy because the number of training cases that Tom Helmuth uses is considerably higher than what we've got here. Like, I think, what did I do? I did median. I think I only have a handful of cases. What do we do here? So an input, where do we actually, here we go. So num training cases, that's a default. Yeah, there's no real optimization going on. And there's lots of discussion about the interpreter. So this is doing 100 training cases. And I think, well, actually, I think that's similar to what Tom uses. We have to look up the paper. But I think that that's in the neighborhood. And actually, since I was doing all of that, I wonder if those tabs are still open. I think median is in here. Am I right about that? That's a good question. I don't know. Oh, come on, really? Want to make me? Yeah, I just figured I probably had the thing, but this wants me to actually log in, and I don't want to deal with that. Yeah, I think benchmarks are frequently a problem. I mean, I think you have to have something, but I think they can be misused. So is median maybe in here? Let's have a quick look because nope, I don't think median's in here. I think median's in PSB1. Poop. PSB benchmark median. Helmuth. Spectre. Get a pages. There's PDF of the full paper. There we go. What? No, don't do that. I wanted the paper. Don't be down. How about a tech report? There we go. Median. Give it 3 integers, print their median. So they did 100 training cases. So they have the same number of training cases. I'm pretty sure that link worked for me recently. So I don't know what happened there. That's very weird. But yeah, so they've got the same number of training cases we do. And we can fly through this. I haven't looked in a while, but because I do feel like I've used that link during last semester, and it worked. So maybe he just broke it. Maybe. Oops. So if we back up to here, that doesn't seem weird to me. I wonder if I can look at the pubs directory and do a little URL hacking. No. Oh, yeah, no, there you go. It goes straight to tilde without a slash. I think you're right. Look at that. Okay, so that was probably the problem. If I put a slash here. Well spotted. Yep, that is almost certainly the deal. Okay. So we get like very good, yes, and that's tiny. I mean, through Twitch and everything. So we, flies through pretty fast on our system. And now if we take out release, it will be slower. Oh, helps if I don't take out quite that much. Well, that one also just got unlucky. But even debug mode's pretty fast. So let's see if we say, no, what do I want to do? target, examples, no, release. Okay, it helps if I spell target correctly. Release, examples, median, boom, right? Yeah. Hyperfine that. So yeah, so we're doing a full run in about half a second. Actually, we have simplification implemented. A very simple version of simplification is implemented. That might be worth mentioning in the. And I think some of the examples, no. Actually, is that here or is that in the course helpers? A semantic simplification. It could be in the course repo still. So we don't, but we were able to implement just the hill climbing drop an instruction. That was really easy, and it did make the results a lot more readable. So yeah, at some point it would be good to, when we're pretty sure we're doing apples and apples, it would be good to do some timing comparing Closish to our system, even a non-optimized version of our system, because I think we would do very well, because these things are so slow in Closish. Okay, so la, la, da, 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 da. Where name is replaced by the name of the example. For example, median. And the optional parameter settings. Wow, good grief. Opt2. Spelling. Words. Hard. That should be a whole new sentence. Provide a set of optional parameter settings that allow you to set things like the population size, and the maximum number of generations, one parameter that is worth how about to consider is, I don't remember the parameter, la 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 la, max initial instructions. This defaults to 100, but runs will be faster and evolved solutions will typically be easier to understand if you start with a small number, perhaps even one. Yeah, so, and we don't have vectors and strings implemented, and so I can't compare that. But I think even these guys are a lot faster because I think the memory management is like really a lot better in Rust. And like we're, let's go to help. Like this is a population size of Oh, actually, that was a very small population. That was 100. So that's actually cheating. Population size, because he uses 1,000. Still really fast though. And yes, it's not spinning up the Java virtual machine, which is definitely an improvement. But we have to pay the price of compiling, but that's a one-time cost up front. So, pew, 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 pew. And actually here with 1,000, we are getting shorter answers in fewer generations because it's just getting lucky and having the right things earlier with the bigger population. And, you know, we can, you know, go up to 10,000. It's slower. Oh, and are we stuck? Oh, and then we're done. Well, that's, so, you know, doing median maybe is the, but I think we have min. So even doing smallest. Oh, but you need a bunch of mins. Yeah. So basically we'll have D, C, B. Where'd A go? Oh, there's A. So I expect most of this is doing nothing, and we're just pushing D, A, C, B on. And then it duplicates this block, so we get 4 int mins, and we need 3, and the fourth one will be ignored. And that solves the problem. But I think if you try to crank Clojure to do a population size of 10,000, the memory management just gets to be a bear. I think it really flails. And that is a significant part of the advantage, I think. That would be something to be explored in greater detail. So vagary, I guess, is a question, since you're here. One of the conversations a couple of weeks back is kind of, you know, where do we go with this? And do we think we can convince EC people to actually use a system like this? If it's, you know, yes, we have to properly document it and blah, 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 blah. So there's stuff that has to be done. But do we think we can convince people to even like try this, or is Rust just going to be a bridge too far for people? Oh, fine. I don't want to deal with all of this. Do I have Slack running? And am I logged into the right thing? That's a good question. Slack. Go Slack. GPTP. Go Slack. Okay, I'll deal with it later. But so, I mean, not knowing exactly what you're pointing at, I mean, do you think that there's any reasonable chance we can get people to care? Or is this really kind of a lost cause? Oh, interesting. Oh, so you do think so? Because it's never clear to me whether people are willing. There's such a history of everybody just building their own system. Not that you, Vagary, have ever built your own system. But, there we go. There we go. Cool. So for uniform crossover, Yeah, exactly, right? And I think there's a lot of people that have never not built a new system. I mean, Ricardo always built a new system whenever he did something. And, you know, there have been some frameworks, some people have put some effort into frameworks, but I think those frameworks are rarely used by outside of the research group that builds them. Sean Luke's Java framework was big, but I didn't get used a lot in papers, at least. And the Lintz group has got their very fancy thing, but again, I don't think it's used much outside of their group. Right, and I think that's the worry. Is the tooling's got to be really convenient, and it's part of the reason I'm somewhat interested in like Python wrappers around all this stuff, because there are a lot more Python programmers than there are Rust programmers, and I think that we can I think we could provide a reasonable system through a Python API that would allow people to get a performant system without having to actually learn Rust. I think where it falls apart as an idea is people are going to want to add their own instructions, and I think writing instructions in Python is going to make it very non-performant. If you're willing and able to do all the instructions in Rust, doing the sort of building the experiment in Python's not bad, but you know, once you want to change things, then it gets to be complicated. Well, but then I didn't separate interpreter versus evolution. I mean, both Izitsu and Justus have been like, you should have those in different packages, and I did not do that. Like, I smushed it all together. I just, you know, I'm working with smart people who are like, those really shouldn't be together. But I didn't, you know. I mean, the interpreter is separate. I know. I teach this stuff. The interpreter is separable. I mean, it's not mushed together in a software engineering sense. So it is actually, I think, fairly easily removable from the package. I think we could separate them into two packages without a lot of work. I don't think we've done some kind of nasty bit of smudging them together and having them interleaved in unpleasant ways. But it is all in one package. But I think they're just sort of sitting there mostly next to each other as opposed to, you know, on top of each other. And yeah, both Izitsu and Justus have been like, we should probably split those out. And they are completely right. So, oops. And that's why, and I like the diagram. That's why we have this note here, that there are essentially two components that probably should be split into separate packages. So that's in the right there in the README, that this is a design issue that probably ought to be dealt with. But yes, very nice diagram. Yay. Should I export it and insert it into the README? Export image. And I need the embed scene. And I want to do SVG, not PNG. Oh, I can give it a name. Uniform crossover.png. Nope, I'm not doing PNG. SVG. Doop-a-doop-a-doo. Okay. And now I want, what? I don't want Discord. What am I doing? There we go. Downloads. move you back over here. Boink. Oh, no, not over there. Over here. Boink. No, not over there either. Find the right window. Thank you. And where is images? There we are. Da-da-da-da. Boop. And then that's going to be in linear. That's over here. And uniform crossover. Trying to figure out what as illustrated below. Illustration of uniform crossover. There we go. I don't know why I've got an over after crossover. That's not good. Uniform. There we go. Nice. Okay, catching up. Well, and there have been numerous conversations. I'm catching up on the DSL comment. We've had numerous conversations about kind of a DSL thing. I think we could use macros to create a way to make it a lot easier to write instructions for our push interpreter. That would be similar to actually how the closures people do it, where you sort of say, here's what stacks the inputs come from, and here's where the output goes, and then all you have to provide in the body is the logic that says, oh, we're going to take X and add it to Y, and that's it, or whatever. We named it Uniform XO in the code. Which is, okay. So, and I know Eustace is a big fan of macros. Macros make Izitsu cry. So, there are differing opinions in the room. I think there's some potentially cool possibilities here, though. That would be nice, absolutely. Although, I mean, it's a little weird. That's probably only really useful in testing, because evolution isn't going to use the macro to make things like that. And so it's, human beings don't make plushie genomes very often by hand, outside of like testing. So I don't know that that would bias a lot, and make it more accessible. Yeah, right. So, and you could, it would be nice to perhaps be able to archive solutions and then bring them back and run them, and a notation like that might be nice for doing that. So there could be value, absolutely, but I think that as far as getting other people to adopt the system, if they can't make their own, instructions and their own stack types, it's going to be problematic. Yeah, right. And actually, like, for and I've never done this, but I've thought about it a lot. Like if you wanted to use some of the cloud resources, so like AWS has a batch thing where you can give it jobs and it will do them on when there's sort of downtime and their systems aren't being used. So they'll hold the job and they'll do it later and charge you less because it's running when they weren't very busy anyway. But there are some issues there where they can stop your run kind of at any time, because if there's a spike in usage from properly paying customers, then they want to take your job off. And so you really want to have save points to be able to use a tool like that effectively. Yeah, so being able to make types and instructions, I think, is really important for people using it. So this started as a bullet list, and I feel like maybe this is not a bullet list anymore. I feel like maybe this is has this become this? And I mean, is that the, yeah, I think that something like that. And then this would be chooses genes uniformly from two parents as illustrated below. Yeah, good. I like that. 2.xo boop bop chooses two random locations along the parent genomes and swap sections as illustrated below. Yeah. So I think that's an improvement. And we can even, if we do more of this, we could even insert a table of contents at the top with links down into various parts for people that are coming back to try to find things. Oh, I see. Sure. I think I would be inclined to repeat the name in this instance. I think that my inclination is to have this be a sentence and not have the information only in the section head. But, okay. Well. Okay, it is 1 o'clock, and I have got a lot of plants to plant. Vagary, I would love to at some point read the paper you guys are working on, and I'd be happy to just wait until it's done, or if you would like to share it earlier than that, I can. Now that was the link to the Slack draft. Okay, so I can try to have a look at that here in the next couple of days and send you some notes. Yeah, I'm still in the Slack. I just obviously have not dealt with it in a long time. So I will have a look, and I hope you guys have a great time. Say hi to people that I know. And I will attempt to be a better citizen and show up in the future. I'm not, having just done a ton of driving, I'm probably not turning around and driving again. So I'll leave you people to your devices. So, oh, okay. I can have a look. Sigh. The problem is I'm going to still be teaching full-time in the spring, so my springs are going to be a nightmare for at least 2 more years. My falls will be very open, but my springs will be a mess. And that makes it hard to say I can do stuff without lying. Okay, now that I'm back, I really need to sort of do some thinking and planning and what do I want to doing. But let's assume for the moment that we'll still have... into the chapter. Okay. Well, then I will definitely offer to help on that front. Next weekend is normal. So Saturday, so that's going to be 7 June. Let me look at my calendar and make sure I'm not lying, but I'm pretty sure that next weekend is well behaved. Yes, next weekend is well behaved. Saturday, 7 June, 2 to 4 p.m. Something fun in Rust. Oh, okay. Hey, we can do that. And actually 2 to 4 p.m. CDT UTC -5. Do we want to be like? Are you? Like we could actually plan to do something kind of interactive that involves them. The thing will end kind of midday on Saturday, right? I could stream earlier if you wanted, like earlier in the week or earlier in the day. I mean, my schedule is pretty open. So if that would be useful. So think about it. I don't know what you'd want to do there. Codicy. Yeah, well, that's the thing. I mean, do I have your text? I will attempt to contact you by some mechanism. I think I do. I think I can text you. Okay, I'll text you. Yeah, I know you're overbooked, and I don't want to sort of insert myself into your process in some awkward way. And then, I'll definitely mention on the Discord if we have an extra stream. It could also be in the evening. Like if you didn't want to insert it into the thing, but you wanted to have it as an optional evening thing, I'd be fine for doing something like that. Now we get too late, and some of these Europeans might find it to be a challenge, but Eustace never goes to bed anyway, as far as I can tell, so it's probably limited impact on Eustace. But yeah, so that could be a way of dealing with it. Well, hopefully not 5 a.m. Because I don't think these people are going to want to be up till 10 p.m. here. Oh, and it's an hour later there, so that would be 11 p.m. for them. So yeah, so I don't think we'd be at 5 a.m., but it could be late, could be well after midnight. So depending on what evening turned into. So Saturday, we'll do something fun. Sunday, 8 June, 10 to noon, CDD, UTC -5. More README fun and documentation. Documentation in EC, unhindered EC. I used to be pretty good at Rubik's Cubes a long, long time ago. But that's been a long time. So, okay, so I'll let everybody go. Vagary, I will contact you by fax. I'll get a passenger pigeon and send it your way. I will let everybody go. I will talk to you later. Goodbye.